Now, yesterday, the first report about what it's doing closest to the sun came out. These are instruments that are capable of looking very close to the sun. And it was realized that, in fact, the object is brightening. It becomes very bright right now as it comes close to the sun, and it's turning blue. And the color blue is very surprising because if there is any dust shed off a natural nucleus of a comet, the dust would make it red. And usually the surface of the object is at least an order of magnitude cooler than the surface of the sun. But what the new data indicates is that the object is bluer than the sun. How is that possible?
This morning, we have a report that the object got much brighter than expected, and moreover, the color of the object is bluer than the sun. And that's very surprising because usually when there is dust around an object, it should make it red. I should also say that the news yesterday was that this object came closest to the sun, and it received a huge amount of heat from the sun. And the latest report indicates that it became extremely bright, much more than expected for familiar comets.
October 29th. For months, astronomers have been waiting for this precise moment. The day 3 I-Atlas would reach Perihelion, its closest approach to the sun. A passage so critical that even the smallest deviation in light, heat, or orbit could rewrite what humanity thought it knew about this strange interstellar traveler. But as the data began to arrive, something felt wrong. The light curve didn't fit the models. The thermal readings drifted out of sync. What was supposed to be a smooth, predictable brightening instead unfolded into something stranger, a rhythm. A flicker that pulsed, not randomly, but almost deliberately. 3 separate observatories in Chile, Spain, and Hawaii recorded it at the same intervals. At first, analysts dismissed it as noise, solar interference, perhaps a sensor glitch. But the timing anomalies lined up, down to the minute, across every independent system. ESA, JPL, and dozens of amateurs all came to the same unsettling conclusion. The perihelion event of 3 I-Atlas did not happen the way physics said it should. Whatever occurred near the sun that day wasn't what anyone expected. And if the numbers held, it would force scientists to rethink not just this object, but the very way we understood interstellar visitors. It began with the simplest clue, the way its light changed. Across 3 continents, telescopes tracked its brightness, how sunlight scattered across its surface, how that glow rose and fell. The models had been refined for months. Based on its spin, albedo, and size, the brightness should have peaked sharply, then faded smoothly into the sun's glare. But instead of a clean curve, 3 I-Atlas's light came in 3 sharp bursts, unevenly spaced, separated by intervals of near darkness. The first flare appeared hours before perihelion, the second exactly at closest approach, and the third, inexplicably, after it should have begun to dim. It looked less like a comet brightening and more like a pulse. Bright, dark, bright again. Each pulse was precisely 0.97 hours apart. When the data reached the minor planet center, analysts assumed calibration error. Solar interference could explain rhythmic noise. But then came the impossible part. The same pulse pattern appeared across instruments thousands of kilometers apart. The same rhythm, the same intensity ratio. Even ESA's solar orbiter, millions of kilometers away, caught it too. This wasn't noise. What made it more haunting was its precision. Normally, as a comet nears the sun, its surface erupts chaotically, jets of dust and gas flickering unpredictably. But here, the light pulsed coherently, as if something on the surface was modulating its reflection. Some called it non-random reflectivity. Others described it as controlled phase oscillation. At peak brightness, 3 I-Atlas reflected 12% more sunlight than its pre-perihelion average, an abrupt, statistically impossible jump. The increase wasn't gradual. It happened in seconds. That led to the first major question. Was 3I Atlas rotating differently? Or was something moving on it? When astronomers re-examined its spin rate, they found it had changed by 14 seconds, shortening by 0.004 hours during perihelion. For a body moving 100 kilometers per second, that kind of precision shift wasn't random. It resembled stabilization, deliberate, not chaotic. Researchers at the Harvard-Smithsonian Center for Astrophysics noted that the timing of this change matched perfectly with the light pulses, as if its spin and its brightness were linked, as though the object itself was adjusting. Skeptics pointed to dust jets. Uneven outgassing can mimic small rotational shifts, but no natural comet had ever shown synchronized, triple-peaked reflectivity across global instruments before. Not even 2I/Borisov, the last interstellar visitor, behaved like this. Then came something even stranger. The final brightness pulse, the one recorded hours after perihelion, came not from the sun-facing side, but from the dark hemisphere, the side turned away from sunlight. That changed everything. If sunlight couldn't explain it, what could? Thermal inertia? Internal luminescence? Plasma reflection? None fit. Some instruments even detected a narrow infrared spike near 850 nanometers, the kind emitted by hot metal, not ice. By midnight UTC, the European Space Operations Center flagged the event internally. Possible artificial reflectivity anomaly pending confirmation. It was never made public, but amateur astronomers noticed the flicker first. They compared exposures online, and within hours the light pulse theory spread faster than any official explanation could contain. Still, no one could explain why 3 perfectly timed bursts came from a tumbling interstellar body, or how it pulsed in rhythm like a signal. And that was only the beginning. The light was the first sign. The heat was the second. Objects passing near the sun follow predictable thermal patterns. They heat up, plateau, then cool, simple thermodynamics. But 3I Atlas broke that rule. Infrared readings from NASA's Parker Solar Probe, ESA's Solar Orbiter, and several Earth-based arrays showed inconsistent temperature swings. Instead of a smooth rise and fall, its heat fluctuated, pulsing in perfect sync with the light intervals. A heartbeat. No natural object does that. Ice and rock absorb and radiate heat steadily. Yet here, one hemisphere cooled while the other heated, as though energy was being redistributed internally. During perihelion, Parker's instruments recorded something extraordinary, a sudden 20% drop in infrared flux, right when it should have been at maximum heat. That would only happen if part of the surface reflected thermal radiation instead of absorbing it. Something with controlled emissivity. Something metallic. At the same time, the solar orbiter caught brief ultraviolet bursts trailing the object, signatures of ionized nickel, cobalt, and molybdenum. These aren't common in comets. They're industrial metals, the same seen in alloys under extreme heat. ESA first assumed contamination from the sun's corona, but the chemical ratios didn't match. The sun doesn't produce nickel lines that localized. It was as though something on or within 3I Atlas was shielding, absorbing, or redirecting radiation, an act of regulation, not chaos. Some theorists suggested a layered or hollow structure. Others proposed outgassing jets laced with metallic dust. But the real shock came from the temperature itself. While the solar orbiter measured 480 K on the sunlit side, Parker's sensors, aimed at the shadowed hemisphere, recorded 960 K for nearly 4 minutes. That's hot enough to liquefy metal oxides. And yet, 3I Atlas didn't break apart, didn't flare, didn't even change brightness. It stayed stable. An internal JPL memo soon circulated quietly. Thermal phase inversion observed. Object emitting more energy than absorbed. That shouldn't happen without an internal heat source. The phrase disappeared from all later reports. By the time the Subaru telescope in Hawaii ran its analysis, the implications were hard to ignore. The object's heat lag, the time it took to cool, was only minutes, not hours. That kind of responsiveness required high conductivity. Possibly metallic. Possibly engineered. Officially, NASA stayed cautious, patchy jets, uneven surface, rotational dust effects. But every theory collapsed under one stubborn fact. The heat wasn't random. It was directional. The hottest point wasn't facing the sun. It was offset by 14 degrees. And that offset lined up precisely with the same vector as the plasma jets that appeared soon after. That's when the anomaly became undeniable. The heat was already behaving in ways nature couldn't justify. But what surrounded 3I Atlas, the halo of ejected material, took the mystery even further. In ordinary comets, jets burst chaotically from random weak points where ices vaporize under solar heat. They twist, flicker, scatter. But when high-resolution imagery arrived from SOHO and the Solar Orbiter, what they saw wasn't chaos. It was geometry. 3 distinct outflows, each emerging from nearly identical positions along the surface. Their angles were clean, symmetrical, forming a near-perfect triangular pattern, a thrust geometry, not a natural spray. If this had been a comet, those jets should have slowed its spin or thrown it off balance entirely. Instead, telemetry showed the opposite. Its angular momentum increased. That kind of sustained stability doesn't happen by accident. The Max Planck Institute suggested an extraordinary but still natural explanation: synchronized venting due to internal fracturing. Pressure points aligned by chance. But others noticed something more unsettling. The spacing was too even, the alignment too exact, as though the vents were positioned with intent. The Solar Orbiter's ultraviolet spectrograph confirmed another oddity. Each jet carried a different chemical signature. One rich in carbon monoxide, another in molecular oxygen, the third, impossibly, in nickel vapor. Nickel doesn't simply sublimate. It takes immense heat to vaporize metal, far more than sunlight could provide. And then, the Parker Solar Probe detected micromagnetic ripples, subtle, rhythmic distortions synchronized with each jet burst. Controlled pulses, not random eruptions. One scientist whispered, "It looks like thrust." The word stuck and terrified everyone who heard it. If those jets were controlling movement, then 3I Atlas wasn't drifting. It was maneuvering. NASA dismissed the idea instantly. Objects don't self-correct in flight. They follow gravity, and that's all. But the data refused to comply. The Hubble Space Telescope joined the effort, cross-checking orbital deviations. Between October 27th and 30th, 3I Atlas's trajectory shifted by a fraction of a degree, just 0.2 meters per second of velocity change, but measurable. And the direction of that drift matched exactly what you'd expect if those 3 jets were acting as stabilizers. The idea of an interstellar body adjusting its course was almost heresy. Yet, there it was in the data. Even more disturbing, the jets weren't diffuse plumes. They were narrow, collimated beams, focused like magnetic confinement streams. Natural comets can't do that. And then the rhythm returned. 3 bursts of light, 3 heat pulses, 3 plasma ejections, each spaced with perfect precision. It was a sequence, a mechanism repeating itself. But the strangest anomaly wasn't visible to the eye. It hid in the timestamps. The moment 3I Atlas reached perihelion, each observatory on Earth, NASA, ESA, JAXA, recorded the same event at slightly different times. 3 minutes apart. For teams using atomic clocks synchronized to the millisecond, that was impossible. At first, they blamed transmission lag. But the delay wasn't in the network. It was embedded in the raw signal. Each telescope truly saw the event at a different moment. Light travel corrections couldn't explain it. The time gap wasn't proportional to distance. It fluctuated, drifting as the observation continued. And then, analysts noticed something terrifying. The timing drift matched the rhythm of the brightness pulses. Every time 3I Atlas flared, time itself seemed to slip. An internal ESA memo phrased it delicately. Temporal discontinuity coinciding with luminosity modulation requires verification. In plainer words, we don't know why time doesn't line up. The Japanese Hinode team proposed gravitational lensing interference, that the sun's warped space-time bent the signal inconsistently. But the math failed. The mass of 3I Atlas was too small for such a strong effect. Parker's magnetometer hinted at something else. It detected a field disturbance 200 seconds before the visual signal, as if the object's magnetic presence arrived before the object itself. That's not how physics works. A field can't precede its source, unless the source isn't just physical. Some speculated about plasma reflection or a transient electromagnetic sheath. Others whispered a different phrase: temporal phase shift. If the object was emitting rhythmic bursts that interacted with the sun's magnetic field, it might distort its own signal timing, bending its light like ripples bending a reflection on water. It would mean 3I Atlas wasn't merely in space. It was slightly out of sync in time. Only by seconds, but seconds matter. When NASA recalculated its post-perihelion orbit, the path was off by over 4,000 kilometers. Something had nudged it. Then came the chemistry. Spectral readings from telescopes across Chile, Spain, and South Africa began to reveal something no one expected: fingerprints of manufactured compounds. Nickel tetracarbonyl, ferric oxides, chromium and vanadium in precise ratios. Those aren't comet materials. They're industrial, manufactured by metal refinement processes on Earth. 3 different spectrographs, 3 continents, 1 result. Too consistent to be contamination. NASA's official explanation was diplomatic: unusual nickel-carbon bonding under high thermal stress. But metallurgists knew better. The ratios were too perfect. Nature doesn't maintain precision like that across hours of emission. Then, ESA's solar orbiter picked up a narrow ultraviolet band, 253.7 nanometers, mercury vapor. Mercury, rare in comets, common in experimental propulsion systems. It appeared briefly, then vanished. Polarization readings added more fuel to the fire. Reflected light came back negatively polarized, the signature of smooth metal, not dust. At Harvard's Galileo project, one researcher muttered what everyone was thinking: it's as if we're watching engineered material respond to sunlight. No one dared say it publicly. Reports were rewritten. Words replaced. Artificial became non-silicate reflectors. Engineered became unusual emission structure. But the truth was inescapable. The object behaved like a machine. Then came the brightening. After surviving the sun, 3I Atlas should have faded. Instead, it grew brighter, 60% brighter within 12 hours. The reflection wasn't diffused like gas or dust. It was sharp, coherent, mirror-like. Subaru and La Silla confirmed it. The albedo had doubled, rising from 0.15 to nearly 0.28 in 6 hours. That's not a comet. That's a transformation. Either the surface changed, or it reoriented. The pattern of reflection pulsed with the same interval as before, 52 minutes. Still rhythmic, still deliberate. Some scientists suggested mirror-plane dust jets. But dust doesn't stay, or others noticed something far more deliberate. The reflection cone always aimed 15 degrees off the sun, perfectly aligned with its outbound vector. It was steering sunlight, like a sail. Acceleration data confirmed a subtle boost, 0.9 millimeters per second squared, small but real, enough to change its course. NASA quietly labeled it anomalous acceleration, the same phrase once used for Oumuamua. But this time, the evidence was undeniable. 3I Atlas wasn't just surviving the sun. It was using it. Its reflectivity changed in ways that optimized radiation pressure, adjusting orientation to maintain motion. To astrophysicists, that meant one thing: intelligence. Whether natural or not, it was reacting, learning. And yet, something even more haunting emerged from the numbers. If its reflectivity doubled, its mass-to-area ratio should have changed too. But the gravitational influence stayed constant. Either part of its mass was hidden, or it wasn't uniform. ESA's internal calculations suggested a staggering result. Estimated mass is almost equal to 3.3 times 10 superscript 1 kg, equivalent to a mountain compressed into 200 meters. Too dense for rock, too stable for ice. And yet, its spin rate increased after perihelion. That's not passive behavior. That's stabilization. Some speculated about magnetic shielding, others about internal regulation, an energy field masking its true inertia. Parker's radar echoes hinted at layered density, as if signals were bouncing through multiple shells of differing composition. Not a solid rock, not even a hollow core. A structure, something built to survive the sun. When its outbound trajectory was recalculated, the truth emerged. 3I Atlas wasn't slowing down. It was accelerating subtly, steadily, in the exact direction of its path. Solar wind couldn't explain it. Outgassing couldn't explain it. The acceleration was constant, rhythmic, synchronized with its rotation. The same 52-minute heartbeat. Parker detected magnetic ripples aligned with each pulse, controlled bursts, evenly spaced, coherent. It looked like propulsion. Some at Caltech whispered magnetoplasma sail, a surface using solar wind and light itself as thrust. And mathematically, it fit perfectly. By late October 30th, it had deviated 4,300 kilometers from its predicted path. NASA updated the models quietly, observed drift consistent with sustained low-magnitude acceleration. But among those who studied the data, no one believed it was drift anymore. 3I Atlas was moving with purpose. And then, without warning, it disappeared. At 9:42 Universal Time Coordinated, every observatory tracking it lost visual contact. Solar Orbiter, Parker Probe, ground telescopes, all blind at once. For 1 hour and 57 minutes, it was gone. The instruments worked. The sensors were fine. There was simply nothing there. When it reappeared, it was dimmer. Off course. Different. Its light had changed from metallic white to neutral gray. The mirror was gone. Whatever surface had been active before had shut down. And yet, the object remained intact. No fragmentation, no debris. During that blackout, Parker recorded one last anomaly, a magnetic polarity flip, lasting exactly 3 minutes. A field collapsing, then restarting, as if something had powered down and then rebooted. When it came back online, its rhythm resumed. But this time, the world was watching more carefully. And what they saw would shatter consensus itself. When 3I Atlas came back into view, the sky felt heavier, as if every telescope on Earth was holding its breath. What returned wasn't the same. Its spectrum had changed. Its movement, its brightness, even its rhythm felt altered. In the 2 hours it was gone, something had happened. No one could explain it. The official logs described it blandly. Temporary visibility loss due to solar interference. But everyone knew that wasn't true. Every instrument, from orbiters to ground stations, had lost it at the exact same moment. Different latitudes, different frequencies, same absence. That kind of simultaneity doesn't come from coincidence. When the object reappeared, its brightness was subdued, its motion slower, its surface matte instead of metallic. Yet, there was no evidence of fragmentation, no debris field, no dust plume. It was whole. It had just changed. Later analysis revealed a single clue hidden in the silence. During the blackout, Parker Solar Probe's magnetometer recorded a sharp field inversion, a local magnetic polarity flip that lasted precisely 3 minutes before stabilizing. Such reversals don't happen spontaneously, not in a vacuum of space, not in that pattern. The implication was hard to ignore. 3I Atlas hadn't vanished. It had turned off. Whether to shield itself, reconfigure, or for something else entirely, no one could say. When it came back online, the rhythm resumed, the 52-minute pulse. But its signature had softened like a heartbeat underwater. The world's observatories scrambled to synchronize their new data streams, desperate to rebuild the lost timeline. And that's when the inconsistencies began. By October 31st, the global data network had fractured. NASA, ESA, and JAXA each released their post-perihelion telemetry, and none of it matched. NASA reported acceleration, 93.7 kilometers per second outbound. ESA reported none, 92.1 kilometers per second and stable. JAXA claimed a slight deceleration, 3 agencies, 3 contradictions, describing the same object in the same 12 hours. For systems built on atomic clock synchronization, this was unthinkable. Analysts compared timestamps, cross-checked frame hashes, re-verified calibration chains. And still, the times didn't line up. Identical images carried different timestamps, as if each observatory had recorded the same moment in different realities. The deeper they looked, the stranger it got. Data blocks were missing, entire packets corresponding to the blackout window. When independent researchers accessed the raw archives, they found gaps labeled instrument dropout. But backups from secondary relay nodes showed those packets did exist, filled with low-frequency oscillations, not random noise, but structured waveforms, repeating at precise intervals. ESA flagged them as possible electromagnetic interference. Others whispered a different word, signal. For 48 hours, the debate consumed every astrophysics forum on Earth. Some called it an error cascade, corrupted data. Others saw a pattern too intentional to dismiss. Harvard's Galileo project quietly compared light curve harmonics with the recovered waveforms. Their conclusion was cautious, almost apologetic. Observed correlations between photometric rhythm and magnetic oscillation exceed natural expectation. Non-random modulation cannot be ruled out. In scientific language, that means it might be talking. But talking how? There were no radio emissions, no encoded bursts, no carrier frequencies, just an invisible rhythm echoing through light and field. A silent pattern that only instruments could hear. Then ESA released an updated chemical report, correcting earlier sensor noise. But inside that correction lay something shocking. A new nickel emission line at 341.4 nanometers. The same spectral fingerprint first dismissed as error days earlier. Now stronger, deliberate. Nickel again. And every time that nickel line flared, the object's velocity changed, fractionally, predictably, in rhythm. It wasn't coincidence. It was synchronization. Nickel in vapor form behaves uniquely under electromagnetic stress. It can absorb, re-emit, and even redirect energy when ionized. Magnetoplasma, researchers recognized the pattern instantly. The emissions mirrored laboratory data from experimental thrusters, micropulses of energy used for controlled propulsion. Every nickel flare coincided with a minute acceleration. Not random venting, not outgassing. A cycle, a system. ESA's internal summary, classified restricted dissemination, stated, nickel-based emissions appear correlated with trajectory stabilization. Mechanism involves active thermal management inconsistent with natural sublimation. Translated, it's managing itself. Even more striking, the nickel wasn't mixed with iron or cobalt as in natural alloys. It was pure, refined, a ratio identical to engineered thermal shields on Earth. The implication was staggering. Whatever 3I Atlas was, it contained, or was made of, manufactured material. By late October 31st, a pattern became clear. Every flare, every thermal pulse, every course correction, all in harmony, all within the same frequency band, 0.019 hertz. Its motion wasn't random. It was rhythmic. It wasn't drifting. It was steering. As its orbit stabilized, something even more impossible began. Its path bent, subtly, precisely, inward toward the ecliptic plane, the flat disk on which every major planet travels, the region where Earth resides. It wasn't escaping into interstellar space like every other wanderer. It was aligning. The shift was slow but exact, 0.7 degrees per day. By November 1st, its trajectory had flattened into near-perfect alignment with the solar system's orbital plane. JPL's orbital software flagged the deviation. Non-gravitational acceleration detected along tangential axis. In plain terms, it's steering sideways. Every nickel pulse matched a fractional lateral push. Each adjustment smoothed the curve of its orbit, guiding it like a hand tracing a circle. To call it coincidence would mean denying every law of probability. By the end of October 31st, its cumulative deviation measured over 6,000 kilometers, enough to change its long-term path by millions. ESA's magnetometers detected synchronized field ripples accompanying each shift, identical in strength, identical in rhythm. One report, later summarized by the Max Planck Institute, read, "Observed course adjustment exhibits coherent acceleration phase matching rotational modulation cycle. No natural jet model reproduces both directionality and stability." In other words, there was intent. It wasn't being moved by forces. It was using them. The object had learned the solar wind, felt it, matched it, and bent it to its will. And every motion since then had pointed to one direction, inward. The implications rippled through every institution. If 3I Atlas was steering, it was doing so deliberately. And if it was deliberate, it had a destination. Models predicted a potential intersection with Earth's orbital path. Not a collision, but a crossing by mid-December. Coincidence, some said. Pattern recognition, others insisted. But in private meetings, the term narrative alignment began appearing in official memos, the unspoken directive to avoid speculation that might ignite panic. NASA stayed silent. ESA fractured internally. JAXA refused comment. And still, the numbers kept aligning, the pulse, the heat, the magnetic rhythm, the orbital bend. It was all converging. Some began calling it the system. Not an object, not a comet, a system, because every part, light, motion, heat, field, operated in synchronization, like components of one machine. It didn't just survive its encounter with the sun. It adapted. And adaptation, by definition, means awareness of environment, of energy, of purpose. By early November, the silence inside the scientific community had grown deafening. Data was being locked down, access revoked, private servers encrypted. The public heard nothing beyond the phrase, unusual comet behavior. But those who'd seen the unfiltered numbers knew better. They had watched something impossible unfold, something alive in its precision. The next revelation came quietly, not from agencies but from amateurs. Citizen astronomers plotting its course independently noticed the same drift. 3I Atlas wasn't leaving us. It was following the path of the planets, orbiting, not escaping, staying. And with that realization, everything. By November 2nd, what had begun as a scientific marvel had become a quiet crisis. Every major space agency, NASA, ESA, JAXA, and the observatories that once worked in lockstep were no longer in agreement. The object that united them had divided them. Publicly, the line remained simple. A highly unusual comet exhibiting non-gravitational acceleration. Privately, the tone had shifted. Inside encrypted threads, scientists stopped using the word comet. They replaced it with a different one, system, not a fragment of ice and rock. A configuration, a construct. No one said machine yet, but the meaning lingered in every cautious sentence. Leaked correspondence from ESA's Heliophysics division included one phrase that spread like a whisper through research circles. The observed course correction remains inconsistent with passive forces. Further speculation about artificial mechanisms must be avoided until narrative alignment is achieved. Narrative alignment, the most carefully chosen euphemism in scientific history. It meant one thing: silence. At NASA's Jet Propulsion Laboratory, the official explanation stayed conservative. Complex solar interactions, variable surface reflectivity, possible outgassing, anisotropy. But within internal memos, frustration grew. Several researchers had already proven that no combination of those forces could explain the uniformity of its acceleration. Their reports never made it past internal review. The European Space Agency fractured into factions. One group clung to the natural explanation. The other, smaller but growing, began documenting the object as an engineered phenomenon. Their language became bureaucratically neutral. Periodic modulation consistent with engineered symmetry. Electromagnetic coherence patterns. Directed energy alignment. To the untrained reader, it was cautious science. To anyone inside the field, it was code. Then came the leak. An astrophysicist connected to the Galileo project published a redacted paragraph from an ESA draft report. It read, "If the acceleration is due solely to solar radiation pressure, the object's area-to-mass ratio would imply an ultra-thin reflective membrane no thicker than 0.3 millimeters. Such geometry, combined with observed structural stability, is inconsistent with any known natural body." The document vanished within hours, but the sentence had already escaped. NASA called it misinterpretation. ESA said it was non-final. JAXA refused comment. The internet, however, didn't forget. Conferences turned chaotic. Arguments replaced lectures. The thermal naturalists clashed with the controlled motionists. One side argued that the data reflected exotic but natural behavior. The other claimed deliberate modulation. Privately, a veteran astronomer at the European Southern Observatory said what no one dared print. "We're not studying a comet anymore. We're managing a crisis of consensus." Access to raw data was soon restricted. Researchers found themselves locked out of servers they had built. Others were warned to stop publishing independent analyses. But outside institutional walls, small teams of independent scientists and citizen analysts took up the work. They ran open-source models, published spectral overlays, shared harmonics data in real time. Their conclusion, repeated again and again: the precision is too perfect. For a moment, the story leaked into mainstream media, a whisper of possible artificial interstellar object. But within days, headlines were retracted, transcripts edited, and the topic buried under layers of official denial. Yet for those who had seen the unfiltered data, the perfect timing, the controlled thrusts, the engineered reflectivity, the denial rang hollow. This wasn't just survival. It was adaptation. 3I Atlas had behaved like something aware of its environment, something that could learn. And then came the philosophical fracture, the quiet realization that science itself might not be ready for what the data implied. Because if 3I Atlas had responded to its surroundings, if it had controlled its trajectory, then it had done something no natural object ever had. It had made decisions. That word, decision, echoed through closed-door meetings. It was never written down, but everyone felt it hanging in the air. By early November, a pattern of internal communication emerged between agencies. Encrypted exchanges used neutral phrasing, signal correlation, mechanical coherence, electromagnetic rhythm, but the tone was unmistakable. They were no longer debating data. They were debating disclosure. Some invoked dormant contingency plans written for non-terrestrial intelligence events, documents that officially don't exist. Others insisted silence was safer. Without proof of intent, they argued, the phenomenon could still be contained as an anomalous natural event. But silence only made the whispers louder. Amateur astronomers had already replicated the nickel emissions. Citizen physicists confirmed the 52-minute pulse. No one could suppress the rhythm anymore. The question had escaped the laboratories. And behind that question came a darker one. If 3I Atlas was built, what was it built to do? Observation? Exploration? Measurement? Something else entirely? No one knew. No signal, no code, no transmission, only a silence too deliberate to be random. Whatever intelligence guided it wasn't speaking. Maybe it never meant to, because the deeper scientists looked, the more it felt intentional. Every oscillation, every magnetic spike, every adjustment in brightness, all executed with the precision of a system operating on principles we barely understood. And it did so without error, without waste, without hesitation, a machine not seeking contact, but endurance. As its trajectory curved gently toward the ecliptic, its motion slowed, stabilized, and held, a perfect balance between sunlight, gravity, and control. It wasn't leaving. It was positioning. Positioning for what? No one could answer. By mid-November, JPL analysts privately admitted what official reports would not. 3I Atlas was no longer following a Keplerian orbit. Its path showed micro-deviations consistent with continuous active regulation. And yet, the magnitude of those corrections was decreasing. Not chaos, refinement. Learning the environment. Optimizing. It was as if the object had finished adapting and settled into equilibrium, like a ship finding calm water after navigating a storm. Inside conference rooms and encrypted channels, one term finally began appearing with cautious frequency. Artifact. Not officially, never in a public paper, but it appeared in internal memos, private notes, anonymized summaries. Artifact. Something made. Something sent. That word changed everything. Because once you accept that something was made, you must ask by whom. And why here? Why now? Trajectory models run by Cambridge physicists estimated the odds of a natural interstellar object aligning this precisely with the solar ecliptic. Their answer, statistically impossible. It could have been random, but probability had long since left the equation. Others proposed a different perspective. Perhaps it wasn't aiming for the ecliptic at all. Perhaps it was using it. A plane of gravitational and magnetic balance. An ideal observational lane for a probe designed to watch planetary systems unfold. Not a rival, a return. Because historical orbital simulations revealed something even more unsettling. Fragments of past trajectories. Objects dismissed as comets centuries ago may have shared near-identical inbound vectors. Maybe this wasn't the first. Maybe we'd seen it before and just didn't know it. That possibility rewrote everything. If it had been here before, then humanity wasn't the discoverer. We were the discovered. Astrobiologists warned that confirmation of artificial origin could shake more than science. It could fracture faith, politics, and the fragile belief that we are alone in our knowing. Some agencies prepared contingency language, no evidence of technological intent, while others drafted full embargo protocols. But the truth was already out. The data couldn't be unrecorded. The light had already spoken, and its silence spoke louder still. 3i Atlas transmitted no message, no radio signal, no coded beacon, only rhythm, pure, patient rhythm, woven into light and magnetism. Maybe it never meant to communicate in the way we understand. Maybe it wasn't looking for conversation. Maybe it came only to observe. Because everything about its behavior, the calm precision, the adaptive control, the deliberate silence, felt less like a call and more like a measurement. A survey, a study, a quiet watching. And perhaps that was the point. Perhaps 3i Atlas didn't arrive to reveal itself, but to remind us that discovery isn't one-directional, that observation flows both ways, that while we've been looking out into the void, something out there has been looking back. By December, its light had faded. The rhythmic pulses weakened, then ceased entirely. No more nickel emissions, no more acceleration, only stillness. 3i Atlas had done whatever it came to do. Now it simply drifted, a faint point of light, receding into black. The official reports would eventually close, filed under unresolved anomalous behavior. The data archives would be sealed. Press releases would return to safe language. Cometary irregularities, sensor noise, complex outgassing dynamics. But the scientists who witnessed the pulses, the phase shifts, the magnetic ripples, they would never forget. Because once you've seen an object behave as though it decided to survive the sun, you can never see the cosmos the same way again. And so, 3i Atlas moves on, silent, distant, fading. But in its wake, it leaves a question suspended across the darkness. Was it a relic of nature's hidden genius, or a message from minds older than our sun? Either way, something changed that October. Something fundamental. Because sometimes the most profound message in the universe isn't what's said. It's what refuses to be.